What's up, everybody? Mm. Hold on, I'm gonna set something up real quick. Woohoo! Hey, how's it going? Just checking out the new setup. Gonna get this beast working again. Check that out. It's missing one magnet though. I'm gonna get that taped in there, and we're gonna have some fun with that. So this is my Trifilar coil, one of them. And the one strand that isn't hooked up in the motor is now generating 12 volts of DC. And it's generating almost half an amp. That's pretty nice. All right, so I'm in a transition right now. We're moving from the table out there to a much smaller table in here. And I don't mind, this table's a lot sturdier. We got 10mm shafts going into this table. Nothing's gonna happen like it happened in the other one. Some people might not like that, but that's okay. I don't like catastrophic failures. That's not cool. Now, why is that? Let's reload this. Huh. Where's all that voltage coming from? It's stagnant voltage. I don't understand. Everything's off. We're getting 7 volts and 250 milliamps. That's a lot. There must be something wrong with my meter, and that's what I'm thinking. But I do know that middle strand, that third strand in the Trifilar, acts as a transformer in the coil. So it picks up almost like a collector extension. It's pretty much what you put in, you get out almost. because we're putting in 12.4 volts and 400 milliamps. And that's basically what we're getting out. So a little less ampage. It's pretty cool, I think. I'm gonna get a light in here. I'm gonna light it up. And I got my ball, my little neodymium sphere here. We're gonna get that rolling in several different ways. Show you the difference between the pancake coil and the bifilar SSG Bedini coil. Just gonna relax a little bit here, let that build up. Got another addition, it'll go right here. I am going to move forward with the sculpture thing. It's going to be pretty cool. So I'm thinking this spherical is going to resonate at around 12 hertz, maybe 11 hertz. Okay, let me zero this out real quick. Move it over. Turn up the voltage a little bit. .5 of a volt. Now we're going to go a little higher than that. All right, we're almost there. We got it. Heck yeah. Now, I don't know if you can hear that. Oh, it stopped. There it goes. That was pretty easy. Awesome. You made a nice little bowl, 3D printed for this thing to sit in, and it's moving like a charm. That's great. $11 hertz. Sorry about the shake. My apologies. Sine wave. 5 volts for amplification. 50 duty cycle. Awesome. Standard, I think. But it's still awesome. All right. That's cool. So over here, the meter appears to be stuck with about 250 milliamps in it, and I don't know what's wrong with the meter, but and about 7.5 volts. It's kind of stuck in there. So I'm going to turn it off for a little bit. Maybe it's because it's plugged in still. That could be it. And so I unplugged it. So 2 volts now. Yeah, that's normal. Should say 0, but I guess there's some activity, like minuscule activity going on near it. So, but I don't know. That doesn't feel right to me at all. And this thing's still spinning. That's awesome. Okay, now I want to do something. I don't know because you didn't hear it the last time. But I'm going to put this in the middle. And we're going to move this up to 100. You hear that? Wow. That's neat. That is really neat. That's 10 hertz intervals. One kilohertz. Whew. Heck yeah. That's awesome. I can't spin it at a kilohertz because it won't. It's not the resonance, but oh, I did it. No, I was gonna say that'd be pretty sweet. Spin it at 1,000. I wonder if I should glue that down. All right. Boom. There it goes. 11 hertz. For this coil, that is. It's a really tiny one compared to a lot that I've seen. Oh, it's cool though. You know why it's cool? Because it's working. That's why it's cool, man. Because it's doing a little bit of what it's supposed to do. Now I have another one, and we can link the two of them together and see what kind of frequency we get off of that. But I do want to show you the Bedini spin after the bifilar Tesla coil spin. Yeah, that's cool. All right. Now, let's see if we've set. No, yeah, I don't know. Maybe it's the bridge rectifier. Could totally be this thing. All right, so I'm gonna go get the Bedini coil that I want to use for this project here. It's not going to be the one that I'm using for the center disc there. It's going to be a different one. But that's a Trifilar. Oh, and check that out, man. We got a variac, well, an AC transformer. We can now do AC power. That's gonna be cool. All right, I'm gonna go grab that real quick. I'm gonna put you back in the stand here. You can watch it move real quick. I'm gonna and on that big rotor, man. That's gonna be sweet. Okay, so this is going to be the coil that we're going to use. It's 16 gauge, so it should give us some oomph, some pretty nice spin. Thank you, I appreciate that. We're going to use the trigger instead of the single generator, and that should provide us with the proper timing. I love that coil though. That's pretty tight. Okay. So this goes here. There. Here. And then you gotta remove the signal generator, and we're gonna put in the trigger. Huh. I got the light. Where did I put the light? Oh, it's over there. I'm just going to need to get 2 more connectors, and we're going to drop our light, our collector to emitter light, and put that in there. Okay. And I call this circuit 1, 2, 3. Oh, come on. Come on. Nope. And this one's broken. Alright. We got one. I don't like, well, I shouldn't have left them on the ground to get stepped on if I don't like broken clips. That is a lesson. That is definitely a lesson right there. Don't leave your stuff on the ground. Alright, not funny. That's a real thing. Gonna put this halogen bulb in between these two clips, and then I'm going to clip it to the collector and the emitter, and that should give us a nice healthy amount of resistance. Alright, and then, oh, I can just feel it. I'm so close. We are almost there. Now we're just going to make sure everything's not touching anything. It shouldn't. It's really close. Alright. Try it with 3 volts first. Yeah. Woohoo! I'll lift it up a little bit. I should probably use my other hand here. See how sloppy that is? I mean, it's so good. There's no like G-spot here. It's all over the place. And it's spinning fast, like really fast at 3 volts. That's pretty cool. We are drawing about an amp and 1.1 amps. Wow, that's a pretty big air gap right there. Wow, that's almost an inch and a half. Wow, dude. I'm just so impressed. I don't know whether it's the coil or the combination of the coil and the bowl and the sphere. I don't know what it is, but it's pretty awesome. That was sweet. Oh. Hell yeah. My dick. GB. Oh my God. So what am I making up, man? What part is a lie? Sir, I'm asking you a question. 3 volts, and it has a frickin' field that goes up to here. That's an amazing coil. You know, my grandfather's name was JB. Julian Burroughs. Hey, Sarah. Nah, man. Oh. Hold on, I need to handle that. I don't like looking at the loser stuff. Let me change this. There we go. He's gone anyway, so I'm happy I don't have to look at that anymore. All right, here we go. So 3 volts. This is a 16 gauge coil with a 26 gauge trigger. This is a neodymium sphere with a north and south side, and that's it. So it's just a bifilar magnet. And it loves to move on this coil. It's going so fast you can't see it, but I'll turn that one off. You can hear it really good. How high is that? That's got to be about 1 inch off the coil. That is so cool, man. That coil is so strong. I love it though. How, man. Oh, nothing's destroyed or ruined. Everything's fine. It's just, I have so much I want to say, is all there is. I love it, man. It's so smooth. I mean, on the pancake coil, it doesn't move as fast by any means because it's not timed. It's timed by the signal generator, which you need to resonate with the sphere itself. That's a pulse motor with a trifilar coil. And this here is another pulse motor with a spherical rotor and a Bedini coil. It's a bifilar coil over here, trifilar coil over there. I haven't named it. It doesn't have a name. It's just a pulse motor right now. And this ball works on 3 volts. And about 1.1 amps at 3 volts. And I think why it's jiggling around in there so much is because of the rotor in the middle. The interaction is pretty strong. That sphere is so smooth. That's cool, man. Since you, I don't know, egg. It's a pulse motor. It's two pulse motors actually. The signal generator is actually for this pancake coil that I have over here. This one right here. There's a signal generator hooked up to it, and I spin that little spherical magnet on top of this at 11 hertz. And that's it, man. I talk about it all the time. Just, whoo, stick around. Yeah, I don't do what everybody, I don't even know how many people have accused me of building stuff that I don't even know how to build. But yeah, man, if you got an accusation, make it up front, please. But I will say up front also that it's a pulse motor that's timed with trigger coils, and each one of these motors is run on its own power supply. That one runs on 12 volts, about half an amp. This one runs on 3 volts, about 1.1 amps. Okay, so this one over here. Yo, thanks, Gavin. You're the man. Definitely not destructive in any way. Unless you build it wrong, and then the magnets can get loose, and that's pretty dangerous. But just don't build it wrong, and it won't happen. Oh yeah, I was gonna show you guys this big rotor that I built a while ago. It's got ceramic bearings, and it's got 12 of these huge neo magnets on it. Well, it's got 11 minus this one. You know, I just disclosed about the magnets flying. This one flew out of here. It's like got Gorilla Glue on it and everything in here, and it just flew out. Oh man. Wow. I'm just off. This coil and this sphere, they go together. They go together, man. This is awesome. 3 volts. And it's going so fast you can't even see it spinning. But you can hear it, man. It sounds like a saw. The benefits of having a timed pulse. So having a trigger coil works a lot better than using the signal generator in my mind. You know, I tried, using the signal generator at 1,000 hertz, and you can't spin it that fast to get it going to hop on that wave. You can't do that. Not with your fingers anyway. I'm wondering if I could like get a reading of how many hertz this is actually moving at somehow, and then put that in the signal generator and see if I can't get it going at least that fast. So something's not right with these readings. So this is the third strand of the Trifilar coil. Yeah, something's not right with it. Because it usually shows 12 volts and about 0.4 amps, which would give it, you know, what it takes. So I'll have to hook this up again. Wow, that thing just started on its own, man. That was freaky. Woo! Did anybody else see that? Did anybody freaking see that? Oh my god. I think it's going too fast now, but I think, like I said, there was a strong interaction between the middle and this ball out here. So I'm thinking when it got to like when it's going slower, I think the interaction is stronger. Like when you turn the signal generator on to 1 hertz and then it pulses at 1 hertz, you draw a lot more amp. Here it goes. All right, let's see what we can do with that. That was cool, man. That was awesome. Oh, it's probably not going to do it again. So you get about a 5, the way it is right now, you get about a 5-volt burst when you turn it on. Like immediately. 5 more volts go through that wire. Yes, sir. Shake it. Yeah, oh, for sure. Shake it. Oh, wow. That's a powerful coil. Hell yeah. Sure. EMF. And then the B EMF can turn on a light if I want it to. But that's not what I don't have any of that hooked up right now. Yes. The electromagnetic field is extremely large with this coil. I mean, I can lift it up about almost 2 inches like this, and it'll still be going. That's a 16 gauge coil with a 26 gauge trigger right there. This is a 32, an N52 neodymium sphere. Man, I'm so happy with this coil. Double what? Double the height? I gotta turn up the voltage to double the height. It's working on 3 volts right now. All right, this is gonna be freaky. This is 8 volts in. Oh my God, this is gonna freak me out. So that was maybe added about half of that to the double. So it's probably about 1.5. But that's definitely a little bit higher than 3 volts. I'll put it up to 10. We'll see what we can get. Whoa. All right, let me because it was humming. It was humming when it wasn't moving, so that means that the collector to emitter connection got stuck open. Wow, man. What? Who's Gerald Wayne, dude? Talk sense and I'll talk to you, man, but I don't understand this dialect. Who is Gerald Wayne? I'll give him a little bit more time, but I don't like that being the last thing on my chat, man. That's not cool. Who the hell is Gerald Wayne? I'm not trying to insult Gerald Wayne, but your buddy here just kind of dropped your name on my channel. That's sorry. I mean, that sounds dangerous, Felix. And I'm sorry about this guy, man. He was taking all that time to write that message, and I don't know, man. I feel like I should undo that. Something about his grandson. I don't even know, man. He was trying to explain himself, and I didn't give him the chance. Ah, that sucks, man. I can't undo it in the way I did it. So I'm sorry. I'll try not to let that happen again, man. That I deal with too much stuff, man. For me, I just need to learn more patience. That's all. Yeah, this is I wouldn't necessarily call it dangerous with the voltage that I'm working at with, but yeah, things can get burnt. And this is definitely two power supply units, so yes. Ah, I see. PSU is a power supply unit, yeah? I'm going to see if the magnetic link between the center and the ball here is enough to get the ball started, because I'm pretty sure it started on its own. I see. Yeah, man. The batteries in series make the voltage go up, so that's probably kind of batteries, my man. What kind of batteries? Yeah, man, that wasn't fair. I wish I could talk to Cody and be like, hey, man, I am so sorry about that. I wanted to give you, oh, man, and then 1 second. That's all it took. But, oh well. I am only going to be sorry for another second, and then I got to move on. Thought he was calling me Gerald Wayne, and I was like, all right, that's not my name. Oh, God. Sometimes I'm just so slow, actually. You can call me slow sometimes. Not today, though. So when I'm done with this table, it's going to be up on a table. Ten volts. That is super spectacular. Alright, I'm gonna turn that off. And as it slows down, it's gonna start to grip this ball, I hope. I see. I understand that, man. I play games with those NDAs. Oh, nothing. There we go. I don't know if it's gonna happen again. That would be sweet though. Felt like it was gonna happen right there. You can hear it humming though. Whew, wow. All right, hey, man, that is awesome. That thing's gonna burn a hole in the bottom of that bowl. mm. Man. Well, I'm gonna take that to heart actually, and I'm gonna learn right now from this experience, man. I feel bad that I canned that dude. I just feel terrible about it. I don't know why. Probably because he didn't deserve it. That 16 gauge is really awesome. And so is that 26 gauge for the trigger, man. It's really cool. It's effortless. Whew. Well, that's been a good hour, man. That's been a really good hour. On to the next one. Sounds good to me. So I got the next disc in my series done here. And it's gonna go right here. See, I got my next 10mm shaft. These are very magnetic too. Like, lots of iron content in the steel. It spins pretty well, especially for a 10 millimeter. That's awesome. But they are steel bearings too, man. A bearing this size, ceramic, just one, and would cost like $25. I don't need to do that. When these are going to spin just fine anyway. Now, I do have lots of ceramic bearings, but I'm not spending the big bucks for these big ceramic bearings. I don't need to do that. So it's going to go like right here. Now the way that I got the shafts in is they go all the way through all three pieces of this plywood out the bottom, and then there's a coupling shaft coupling goes in the bottom, and then you screw it in so that it straightens out. Then you put one on the top and you screw it in so it straightens up and it gets solidified. But the coupler flanges, like if your hole, you need to make your hole a little bit bigger, so that way it has some wiggle room to straighten up if the hole itself isn't straight. So you might need to make the hole a little bit bigger than the shaft, and then those couplers will straighten it out and center it and attach it to the wood. That's going to be sweet. And I'm going to make, I'm working on a magnetic, like, it's going to be like a spiral staircase on each side of this. And it's going to go up and connect to the pole that's over there. And that pole is going to go up on this side and connect to the pole that's over here. There's going to be, let me think here, 1, 2, 3, 4, 5 discs in each set of stairs. Boom, 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 boom. You know what's really not cool? An EMF field, an electromagnetic field that can't repel another electromagnetic field of the same kind. Something, I mean, if it can't do that, then in my mind it's not worth doing, because what I need to do is I need to build a Tesla coil, like one of the erect ones, not the pancake one. But it's not going to be, the field has to take on physical properties. Like it has to be able to repel or hold the same field of something that might weigh tons above it, and repel it. It should be able to do that. And since it's all electromagnetic anyway, it should be adjustable to that frequency that will repel, and not an opposing, but the same, so it will repel. And there you go, man. You put it on intervals on your road, and there you go. Your cars can fly. All you got to do is attach the Tesla coil to the bottom of the car, have the Tesla coil on the road, and those two should repel each other. If they can't do that, then I'm crushed, man. Then it's like, wow. I mean, because that's it. We don't just go in the ground for boring and because boring is boring. We want to fly. We don't want to go in the ground. Of course we're going to go in the ground. It's easy. It's easier than finding a way to fly, for everything to fly. It's easier than that. You just build a big old drill that's on a toroid and plow your way through, man. That's what you do. But I think that the train mechanism for the speed trains, the Shinkansen trains, uh, those are awesome. Yeah, I built quite a few gyroscopes actually. Well, kind of rotating pulse motors is what I like to call my gyroscopes. Yeah, I built three, I think. Let me think here. One, two, three. One of them is really, really cool, but I broke the rotor. It was going like 2,800 RPMs, and the magnet just flew out the side, busted open the 3D print, and just flew out the side, and then the rest of it went exactly 180 degrees the other way. Check out my birthday stream, man. It's I got it on a stream. It happened on the stream, man. That's pretty cool. I mean, it sucks, but the fact that I got it is pretty cool. I think all my catastrophic failures I have on some form of video. Well, I ran three at the same time with the same power supply. So, yeah. But this table could definitely house a few. But I have to rebuild them all because the ones that I have are all 1/4 inch shafts. Here, I'm going to go get my stator for my axial flux. Okay, so this right here is a stator for an axial flux gyroscopic pulse motor. You've got a 20 gauge drive circuit, and you've got a 32 gauge drive circuit, and you got a trigger coil right here which fires off both drive circuits simultaneously. And then it's 24 volts. We have two battery packs, 12 volts, linked in series, that run the transistors over here. It's maglev. So this thing spins like a champ, man, and it spins the opposite way the rotor spins. So that's awesome. Huh? See, the diodes here kind of chose the direction for me. So when I made it a DC gyroscopic pulse motor, the direction that the diodes are all facing is the direction that the stator is going to go. Oh, but the rotor itself is gone. It broke. Need to make another one. Should probably make another one of these too, one of these plates, and then just move all this over to a plate that has a 10 mm hole in it. And there's no reason to change this one at all. It's perfect the way it is. So that's all I have to say about that. Now, a new one, I'm all ears for suggestions. All right, let me get my other gyroscope. Well, part of a gyroscope. I've cannibalized most of my old ones. But this one, and this, it works with commutator brushes. You can tell that I haven't used it in a while by the shape of the copper. So there's two. I got the rotor for this one in the other room. This one's pretty awesome. This was my first one right here. It's magleved. You can see it bouncing. Sweet. I'm gonna grab that rotor but it doesn't have the maglev on it, so I can't put it on there. Now you see how this metal casing is it's for the bearings, so it doesn't wear out. This little rotor right here had a maglev on it right here, and it would be perfect. And see, like, it'll counter rotate, but you need that maglev in there. And maybe even all the magnets too. I mean, and this one runs on a reed switch. That's how I had this one running. Because these magnets on this one are not very strong, so you'd have to whip it pretty hard to do a trigger coil. This one was my first, like, I would call it a triumph, because I literally just didn't know what I was doing, but everything kind of just fell into place as to how it was going to come together, like how I was going to build it. And I did it in like 3 days. Made all these pieces, decided how big they were going to be. It all kind of fell together. You got the perfect air gap there, your reed switch, and this thing just one went one way and the other went the other way, without me even doing anything. All I had to do was turn it on with the reed switch and make sure that it was engaged, and everything happened on its own. So I'm thinking that this counter rotating business is a natural occurring thing. It happens once you get everything set up so it can happen. It'll happen automatically. And if it isn't happening automatically, you probably have something either you're not putting in enough voltage for your system, Trust me, put up the turn up the voltage, it'll probably work better. That's why this one has 24 in series instead of 12 in parallel. You know, that's why I've turned up the juice with this one, and it moved really really fast. It was great. But this one is a beauty. This one's kind of ugly. This one, these are 32 gauge coils all the way around. Um, I could get it all the way up to 50. I'm turning my voltage up all the way into this thing, and it would run super good at like 60 volts. You know. So I'm gonna find one of my mag labs. It's probably all over at the storage place. I might bring this one back to life, man. I'm glad I got it out of that corner over there. So these are all in series, all these coils. And then you got your thicker gauge wire brush. Just touches that commutator. You get your positive and your negative. It's really simple. You just got to have enough money to get yourself a sheet of copper, a 1 pound roll of 32 gauge wire, a bag of clips. Be good to have a 3D printer, but don't think you really need one. You could use any type of thing that's like an L shape, and then like a platform for your coil, because you want to get those all at the same height and level with your rotor. And then you want to make your reed switch placement so that it's easy to switch them. If you need to switch them out, then you want it to be easy to do. And then, maglev everything. Wow. So the negative plate is right here in the middle on top of a maglev magnet. And that's what's keeping it separated from the plate below. So these are two separate pieces of copper right here. These are counter rotators, counter rotating pulse motors. These two up here are pulse motors. This is a trifilar coil. This is a bifilar coil. This is a spherical rotor. This is an old one though. It's in pieces. So I'm just explaining, how I built it, how you can build it. It's virtually like this. This is the stator, okay, where the outside where the coils go. How it's usually just still and held still. You make it so it can spin. There could be various ways you can do that. It's maglev, so it spins graciously. The stator is spinning graciously. And then you got your rotor, and that kind of goes. Once I get a magnet for it, it's going to settle like right there. And then one's going to be able to go one way, and it's going to be able to go the other way. And I'm telling you, once you get this engaged to the point where it's working, one's going to go one way, and the other one's going to go the other way automatically. You're not going to need to do anything. You just put enough voltage in and engage it, and it should work. What is it for? What does that mean, bruh? I guess it makes electricity. I mean, I don't know. What do you want to know? Huh. It moves. It moves graciously. It makes electricity. The only electricity that I'm actually monitoring at all right now is the third strand in my Trifilar coil. So the Trifilar, the center coil or the third strand, right now is generating, let's say, 8 volts of DC electricity and 250 milliamps of DC ampage. Wow, that ball wants to move. I feel like I should glue it down, but huh. I don't know, man. I don't do that dark web stuff. So this is all just pulse motors. And that's 3 volts in on this one over here. That's awesome for 3 volts. You could be a little less rude, and maybe I could address you. Huh. I know. Yeah, I got much better readings on this. Yeah, it's all right. I mean, unless you're some kind of billionaire philanthropist, I'm gonna get rid of you, okay? right, moving right along. Oh, there it is. 1, 2, 3. My amps. I love 1, 2, 3. That's what this. That's what I call this circuit here. Is one. Woo! All right, we gotta turn that off. See, 1, 2, 3. And it's even like the base, the collector, and the emitter. 1, 2, 3. Oh, that's so beautiful. 1, 2, 3. And it works so like awesomely. And you got your light for resistance, and then you got your 3 that connect. Boom. And then you just hook your trigger coil. The butt end of your trigger coil hooks to the emitter, and you're golden. Instead of grounding it, you just hook it to the emitter. Wow, dude, that one, yeah. That started up on its own. Holy cow. Woo! All right. So I'm going to get this going. We'll see how many amps we get. We're at 100 milliamps right now. We got lots of different pulse motors going on here. These two are kind of rotators, are part of kind of rotators. And these two are Bedini style coils. This is a trifilar. This is a bifilar. This spherical N52 rotor. And my little UFO rotor in the middle. Something's wrong with this connection though, man. This is not... It's not right. Trying to see if there's any like connection thing that is happening here. Alright, let's get rid of the bridge rectifier for a second. We'll just do the AC run. All right. Turn that on. And we'll hit boom. What the hell? Man, okay, I don't understand. I'm gonna have to figure out what's going on with this coil. I don't even like that. I'm gonna have to get over there. No, I think it has to be the meter, honestly, at this point, anyway. So I've got another meter. So this jumble of wires over here, this 1, 2, 3, goes to this pulse motor over here. And then there is a jumble of wires over here that goes to the center pulse motor. All right. Kudos to everybody having a blast out there. I really like what I see. And it's really a lot about what you see. Okay. We're going to get some of this jumble out of here. We're going to get it out. We're going to get it out. Oh man, this one is really bad. There we go. Those two are out. This one is out. This one is out. Okay, let's clip. That one there. This one here. And this will tell us whether or not it's the instrument So that says 9 volts of AC, 10.2. Okay. Still not great. Haha. Okay, so that's that. Maybe we can put the DC rectifier back into play. So I'm going to do this one. And we're going to do this one. get shocked. I'm gonna move these two to the DC side, diagonal. And that's AC. Let's look at the DC. So about 12 volts DC. It's really fluctuating though. 9, 10, okay. Oh man, I feel like I have to make a new coil because it's not working the way I want it to. But this is an extension basically, a collector extension almost. The third strand of the Trifilar coil acts pretty much like a transformer. But as you can see, it's not working very well right now. It's supposed to be more like a one-to-one transformer. That'll pick up from both of the other two strands. So like the drive coil and the trigger coil will both affect the transformer coil. It's just that the drive coil will affect it more than the trigger coil. The trigger coil does produce electricity though, so it will affect the third wire, the third strand, just from being there. Good Lord, what happened? Haha, my stream reset. That's awesome. Or maybe it's just the time is wrong. I don't get it. The time reset, that's for sure though. It's alright. I mean, it's weird. I don't get why that happened. Woo! That was close. Alright. So I am going to move forward with the sculpture that I want to build. I don't know where I put it. My other rotor. It looks like the one in the middle. Oh well. I'll find it. So what other things? Got the pancake coil. But I don't know, man. I use the pancake coil to spin the sphere, and I think the Bedini coil spins the sphere 100 times better. Hell yeah, man. That's awesome. Oh, here it is. Yeah. So this one will go about right here, and it'll level off and it'll be the same height, and they'll interact coupling one another. There's going to be 5 discs on each staircase. So it's going to start with the center platform, and it's going to move around to the opposing, the 180 degrees is each going to have a platform at the same level as the center. And then one's going to go here, so it's going to go from here to here, and this one's going to move up and interact with this one, except that it's going to be elevated. And here, it's going to be elevated again, there, elevated, and then finally we're going to go 180 degrees over to the other pole, and then the 5th one's going to be up here like this. So that there's going to end up being 2 discs on these poles right here, on these side poles. And the goal is to have them all move with one coil, or one power source, you know, have it not be complicated, is basically what the goal is. Have all those discs moving simultaneously at the same speed using only one coil. I don't know if I can do that. If I have to add another coil, then I have to add another coil, but we're going to try. I wish there was a way that I could like make a 3D model of this, because it's really cool. Oh. Got those big badass magnets on this thing. One of them popped out. We're going to fix that, and we're going to tape it. We're going to make it so they don't pop out anymore. Then I'm going to use this bad boy to generate some electricity. There's 12 of those big Neos on there. They're N52s, and they generate a lot of electricity. A different way than, say, a Bedini style generator. Yeah, I could do that. I'm going to grab that coil right now. Alright, so this is an 18,000 turn 32 gauge coil with a soft iron core. And all it does is sit there and let the magnet pass it, and that's all it does. I'm already going to tell you can light a 100-watt light bulb with ease, and then have like 2 amps left over from the ampage and the voltage that it uses to light the light. It has about 2 amps left over. But now that my meter's freaking acting up, I don't even know, like, okay. Now you saw how we got about 9-10 volts on the for those of you who are just showing up, if you just got here, I'm loading up this coil. We're going to see what it's going to generate. Okay, here we go. I'm going to turn on the power. I'm going to turn on to single digit. Oh no, it's on the bridge rectifier, so do single digit DC. Here we go. What? Okay, now I'm confused. Now I think yeah, let's get rid. It could be the bridge rectifier even. I don't know where the kink is in the armor here, but it's definitely out there. 0 volts, man. That's where we're at. The 0 point energy is fantastic. Sorry, the pun. Alright, here we go. Okay. There it goes. Wow. I think that the Halbach array is going to give me way more voltage of any kind than what I'm getting right now, man. Because oh, I don't have any like ambition, Bob. This is a DC brushless motor, and this is a Trifilar coil that's running it. So you got a trigger coil, you got a drive coil, and then you got a generator coil or a transformer coil, all wrapped up in here. Okay, and then this one is 1,800 turns or 18,000 turns of 32 gauge. And it's got a soft iron core. It's registering the voltage right here, which is 65 AC volts, which is really low. I don't know what's going on here. I think it might be because I'm not using the Halbach array. and I was for all the other builds. So I think I might actually change that up. Change up to a Halbach array real quick, like right now. And so this one's generating AC currently. It's about 66 volts of AC. This is a pulse motor. It's got a bifilar Bedini coil with a trigger of 26 and a drive of 16 gauge. Got a spherical rotor. So this bad boy will spin like tremendously fast. Here you got two counter rotating pulse motors. Thank you, Alien Grant. I appreciate that. Let me think. What am I doing? Haha. Now there's like an extension, an SG extension. Is what I call it. You connect a collector to another collector via diode, and it should virtually pass the power from the power supply to the second transistor through that connection with virtually no loss. No loss there. So I don't know. I definitely call that exponential gain. That is definitely exponential gain. That is pretty cool. I mean, it will draw a few more amps, but the voltage will stay the same across the board. So, but yeah, the amps definitely will increase the more connections you add. So right there, I definitely would not call that free. It's not. Cost amps. Each connection costs amps, and the parallel connection of the voltage is what I find to be pretty cool. You know, it doesn't diminish. So we're gonna. All right, now it's generating 72. But I still think, yeah, I gotta get my little wand. Find that real quick. Got it. Nice. All right, and here's number 3 counter rotator. I just don't have the rotor for it. Okay, and then I got my tach meter, so we'll get some speed readings. I need just a little magnet. we're just looking, we're changing these around so I can see if the Halbach array so we want to find north. We want to make it go that way. So now it's right there and it's facing up. Okay, so that's what we want. All right. Wow, that one's a little tricky. So that's 3. Now we just need. See, and now it won't. See, the iron won't attract that because, at least not directly on it. It'll be right next to it because that's awesome. And that's what I noticed, that when you put it north facing out, it'll attract to the iron. But when you put it Halbach style with north-south facing out, it's totally different. Oh man. Oh man. Perfect. All right, let's give it a rip. All right, so we're drawing less amps, which I knew we were going to do. But here, let me turn this up a little bit over here. So 80 volts now, that's a lot better. Here we go. Yeah. It's like the second wind just kicked in. And we're at almost 16 volts right now and 600 milliamps for the motor in the middle, and we're generating it looks like 114 AC volts. $120. Yeah, the Halbach is sweet, man. It's awesome. This is the south version, so I spun it like this, right? I spun it clockwise, so all the souths are pushed on to make it go. So north will pass and the south will get pushed. Spin it the other way, it's the other way. You're pushing on south going this way, you're pushing on north going counterclockwise. Let's see what we get. Yeah, look at that. Look at that thing go. Woo-wee. 127, 128. Oh yeah. My halogen bulb is lighting up. Maybe you can see it. Yeah, it's the one over there. It's lighting up if you can't see it. Here, let me turn the light off. Maybe you can see that then. No? Kinda. But that's 120 volt bulb instead of the 90. It's like putting it up a notch. I got some of the 90 bulbs too, but at this rate they probably burn out, you know? Or get really, really bright. Oh yeah. So now let me hook back up the bridge rectifier. This is come on, there we go. Okay, just so we're good, the bridge rectifier is hooked up on diagonals. You got your in here and your in over here. They're on diagonal. That's AC ins. And you got your DC out right here. You got your ground. Let's see what we get. We'll go here. Turn it on. Go the same way with south, clockwise. So we're at 50 volts. Now there's another coil that I use to go along with this big 32 gauge coil, and it provides a little bit more ampage because it's 26 gauge coils and two 32 gauge coils in parallel. So wow, 88, that's cool. Let me grab that. All right, so I got a load here. I got a light. I got the extra juice for the coil. This is it right here, man. This thing is really cool. Logo right there. And then I got the 100-watt light bulb. It's supposed to be the equivalent of a 1,000-watt metal halide bulb. Okay, so yeah, 100 watts is accurate. Alright, so we got that. Let me turn this off for right now. We're going to take the butt end of that coil and we're going to plug it into the front end of this coil. Okay, now we're going to take the butt end of that coil, we're going to plug it into the bridge rectifier. So this is all of that hooked in series. You got 8 26 gauge, and two 32 gauge reps. I believe there are 333 turns of each. All right, let's give it another shot. So that one's hooked up right. I mean, it's just when it goes up more rapidly, that's it. That's good. Wow, it's like fluctuating. It's going down a lot. I wonder what that's all about. It could be the Halbach. Uh, wow. Looks like it's actually less, doesn't it? That's funny. To me, that's awesome. All right, I got an idea. I do. Remember what I was just talking about? All that, it increasing faster. So I'm gonna try swapping these. Already looks worse to me. Oh. Yeah, that's not right. Okay. Okay, so I'm wondering if I put this coil first and then have that coil at the end. Okay, so if that's the case, then this one will go here. And then this one will go here. This one will connect to the bridge rectifier. And I'm also going to hook the light up to the bridge rectifier. I usually like seeing how many amps are left. Because it does require some small amount of current to get this light lit. And I'm thinking that it shouldn't because it's an LED, but I think to get it bright, you gotta get some current through it. Oh man. So yeah, I think everybody that I kicked today, I'm gonna go into my channel and I'm gonna unkick them, and they can come back if they want. I prefer that if you're gonna, just I don't know, man. There's some things I don't know about, I guess. But I'm gonna unblock everybody because that doesn't really bother me that much, truly. All right, there it goes. Let's turn it on. So I just turned off the light. I'm gonna turn it on. There it goes. Yay! Sound very dim though. Yeah, see, there's something not right. I think it's the connections. I think it's the clips. It's gotta be the clips. All right. That's that, and this is gonna go right here. That's gotta be where the problem was. Cause I just picked this up, I didn't unclip it though. Yeah, that's no good. These look like they might be alright. Alright, clip is good. Clip is good. Alright, and then this one will go right here. I'm just gonna use the one coil right now, not this one. Alright. so weird. That sounds sick, doesn't it? Oh, all right. So gotta get this jumble of wires straightened out. There we go. That's it. Oh. There we go. Yeah. Well, something's not right with this. It's probably because there is too much going on over here. Oh, yeah. God, what happened to my time? Because I thought I was already up for an hour and a half, and now it's like 55 minutes. So I'm getting tired, and I don't know why. Let's get an oscilloscope reading real quick. We'll get it on that third strand. Oh man. Alright, here we go. That's like instantaneous D right there. It's like, he's from the D. Holy cow. Alright. So that's our oscilloscope reading for the Trifilar coil. with the Halbach array for the magnet spread. Oh, that's pretty cool. All right, let's check. No amps though. That's not right. Oh, that's DC. That's DC. I think it's not right though. Yeah, that's not right. Yeah, I don't know. I don't know. But I know that it gives me better readings than that. There's the AC voltage for that strand. So that's the AC voltage. Now watch it when I turn it off. So that's all from transformer activity going on inside the Trifilar coil. And it's about 10 volts that you're getting virtually free just from having an extra strand in your coil. Pretty cool, I think. Now, I want to try something else. I want to hook this directly up to the multimeter. This is a long end. I'm going to have to change this. Very long. See, there you go. 135 AC volts. That's more like it. Now let's see about the amps. There it is. There it is. That's the DC amps. And it's probably going to be more with DC. Let's check it out. Yeah. With the AC amps, it's 380. And DC amps. See, but I don't understand why I'm getting DC amps without a bridge rectifier. I don't understand that. But those numbers are more probably what's going on, because it takes more than just voltage to light the light here. Wow, there's like a lot of fluctuation in the speed of the rotor. So I'm thinking maybe some graphite powder or some light oil. Because those bigger bearings, they don't spin as well as the little ones. That's sweet. But yeah, I'm thinking I'm gonna call it and clean up. And check you guys again later for sure. Thanks for hanging out. I really appreciate all the input and curiosity. It's all gravy. Thank you very much. Peace out. Check you later.